First thing we want to do here, we want to rewrite our fractions. So we've got the 5x cubed still, plus 4x, minus, rewriting the 1 over x to the fourth, we get x to the negative fourth. We're going to leave the 3 over x as is because that's just a special antiderivative, it's a special function. And then we've got our constant of 7. So a little bit of a rewrite. Now go through term by term, apply our little power rule for taking antiderivatives. On the first term, we're going to add 1 to that power. Power was 3, power is now 4. So we got x to the fourth. Take the reciprocal of 4, which is 1/4. 1/4 gets multiplied to 5 in front. 5/4 x to the fourth is the antiderivative of 5x cubed. Continuing on to that 4x, power on that x is 1. So add 1, get 2. New power at 2, you look at the reciprocal of 2, which is 1/2. That gets multiplied to 4 in front. Get 2 back. 2x squared is the antiderivative of 4x. All right, minus. We've got x to the negative fourth, so if you add 1 to that power, you've got negative 3. Reciprocal of negative 3 is negative 1/3. Negative 1/3 goes to the front where there's already a negative, so it's plus 1/3. All right, special guy right here, 3 over x. If it's ever just over x, when you take the antiderivative, you have to remember that the antiderivative of 1 over x is the natural log of the absolute value of x. You just have to remember that. So since there's a 3 there, we'll say 3 natural log of the absolute value of x. For the constant, plus 7, we're going to attach an x, because to check, if you took the derivative of 7x, just be 7, right? Takes you right back up there. And since we've gone through all the terms now, taking our antiderivatives, the last thing you do is you add that constant, and you're done. All right, so we're bringing up that square root. We're raising that root in the process as we bring it up, and because we're bringing it to the top, negate the power. So it's x to the negative 1/2. We're recognizing that x plus 2 is something we can expand out if we're squaring it. So take x plus 2 times x plus 2, FOIL it all out. When you FOIL it out, you should get x squared plus 4x plus 4. Okay, we're not at the point yet where we can just take the antiderivative because we need to have single terms to play with. We've got some multiplying that still needs to take place. So take that x to the negative 1/2, distribute it through. As you distribute it through, you got like bases. So we're adding exponents. X to the negative 1/2 times x to the second, negative 1/2 plus 2. That's going to be 3/2. Plus x to the negative 1/2 times 4x. That's a 4x to the first, so it's negative 1/2 plus 1. Your power would be 1/2. And then x to the negative 1/2 times that plus 4 is just plus 4x to the negative 1/2. So now we've got individual terms. We can take the antiderivative using the power rule. We add 1 to this first power. 1 plus 3/2, that's x to the 5/2. Reciprocal is 2/5. Move that to the front. Plus, on the next term here, power is 1/2. Add 1, get 3/2. Reciprocal is 2/3. Multiply the 4 in front, get 8/3. Plus, we've got a negative 1/2 power here, so if you add 1, you get 1/2. Reciprocal of that is 2. Multiply 2 to the 4 in front, get 8. Taking the antiderivative of each individual term, so tack on C and you're done. Alright, so on this one, we want to bring up that quantity. That quantity will join the 7x squared on top. So quantity of 16 minus 7x cubed. Power was 4, so now it's negative 4 since we're bringing it up. Yeah, this problem involves the substitution technique, so it makes sense on this problem to let u equal the part inside the parentheses, 16 minus 7x cubed. And this is where, when we introduce that new variable, I encourage you guys to set up a new problem. Start that setup. So setting up a new problem over here, introducing u now into the mix. The u represents this quantity, which was raised to the negative fourth. So I write u to the negative fourth over here. But going back and looking at what I still need to replace, the 7x squared and the dx, since I don't have that combination, that's where we take the derivative of this equation. Taking the derivative of this equation, u becomes du. 16 goes to 0. The negative 7x cubed becomes negative 21x squared. And then we got to remember that little dx. So looking at what I'm trying to replace, I'm trying to replace a 7x squared dx. I'm awfully close right here with that combination. We got the x squared, we got the dx, but we need the 7. So what could I do to both sides to make that 7 happen? I could divide by negative 3, right? If you divide by negative 3 to this du, I write negative 1/3 du. If I divide by negative 3 to this side, well, that gives me that 7. And I still have that x squared dx. So wanting to take the 7x squared dx out, I can, as long as I replace it with what it equals down here. So there's my new and improved problem that is much easier to take the antiderivative of. So as you take that antiderivative, add 1 to your power, get u to the negative 1/3. Reciprocal of that negative 3 is going to be negative 1/3. So negative 1/3 gets multiplied the negative 1/3 in front. Get positive 1/9. That's all you have to do in terms of taking the antiderivative here. Now just tack on c. And remember that we have to finish in terms of the same variable that we started with. So variable was, in terms of x, u was 16 minus 7x cubed. So replace u with that. Let's raise the negative 1/3 power now, plus c. All right, so same kind of approach to get started here. We're going to let u equal the part under the root. U is going to equal 12 minus 4x. So you introduce the new variable, you set up the new problem. That u expression was under a cube root, so I'll write u to the 1/3 over here. Meaning the only thing I have to replace at this point is a 4x and a dx. So I'll take the derivative of my equation I've set up for u. Taking that derivative, we get du equals 12 goes to 0. We got negative 4x, so that derivative is just negative 4 dx. Looking at what I'm trying to replace, a 4x and a dx, I've got some of that combination now because I have a 4 dx here. I could divide the negative over. Since I have some of that combination, let's go ahead and plug in what we can use. We'll be able to take the 4 and the dx out if you replace it with negative du. So I'll put a negative here. I'll put a du over here because I still have some variables to adjust for. Right? The sticking point on this problem is this x. So does anybody remember what to do when you have that little leftover x, that little leftover variable? It has to do with this equation right here. Remember what you do with it? There we go. We're going to solve for x. If you solve this for x, subtract 12 over, and divide by negative 4. Dividing this u by negative 4, that's going to be negative 1/4 u. By negative 12 by negative 4, get plus 3. So here's an expression we can use to replace this x up here. Since that's an expression I can use, I'll substitute in. I've got negative 1/4 u plus 3. And now, it's awfully colorful, but everything is accounted for. On this new and improved problem we've created, we can't take the antiderivative just yet because there is some multiplying to do, so we got to distribute. As you distribute, that negative u to the 1/3 times negative 1/4 u, well, it's going to be positive 1/4. Add your exponents because of your like bases. Power here is 1, power there is 1/3, so that's 4/3 if you add. And then negative u to the 1/3 times 3 is just negative 3u to the 1/3. There's your expression you're taking the antiderivative of. So, adding 1 now to our powers. Got u to the 4/3, add 1, it's u to the 7/3. Reciprocal is 3/7. That gets multiplied to the 1/4 in front. That's 3/28. Minus, add 1 to the power here. You've got u to the 4/3. Reciprocal is 3/4. Multiply the 3 in front. So that's 9/4. Squeeze in my plus c there. Now we've taken the antiderivative. And just like the last one, got to make sure everything's in terms of the original variable. So take the u's out. And in place of those u's, we put the 12 minus 4x back in. Okay. We're going through term by term here. You take the antiderivative cosine of x. You know, cosine and sine go together, so I write sine of x. And to check myself, if I take the derivative of the sine of x, does that give me cosine of x? Well, yes, it does. That means I must be right. Then we add on. You've got this 3 sine of x, so 3 in front of the trig function, just coming along for the ride. Sine of x goes with cosine of x, so cosine of x gets factored in somehow there, right? But to check yourself, if you take the derivative of the cosine of x, well, do we end up back over here? The answer is no, because you need a negative, right? So since this sign doesn't match up with this sign when we check, we got to change the sign. Okay, last term, you've got a minus 16 secant squared of x that you're taking the antiderivative of, so 16 stays. Only question is, do you remember what the antiderivative is for secant squared of x? Tangent. Derivative of tangent is secant squared. So we've got our antiderivative for all the terms. Process is complete, so add on your constant. Can't multiply it out, right? So the 6th power. So, all right, set up a u equation. U equals stuff inside parentheses, 4 sine of 8x plus 3. Introduce the new variables, set up the new problem. So on the new problem, u was this piece. It's being raised to the 6th. I write u to the 6th over here. Now figure out how you're going to accommodate the 16 cosine of 8x and the dx. Of course, the leftovers, we understand, come from taking the derivative right here. So when we take the derivative right here, we get du. You got 4 sine of 8x. So 4 stays. Derivative for sine of 8x is going to be cosine of 8x. Anything else? Times 8. Remember, you have to take the derivative of that 8x. 3, of course, that goes to 0. So clean it up a little bit here. The 4 and the 8 I can multiply together. That's 32 cosine of 8x. What have I forgotten? Anything? dx. Yeah, we need that dx. I'm trying to replace it. So now we got enough to play with to replace these pieces up here. What would make sense to do to both sides, though? Divide by 2 because you're trying to create a 16, aren't you? So divide by 2, get 1/2 du equals 16 cosine of 8x dx. Since 16 cosine of 8x dx equals 1/2 du, and that's what I'm trying to replace up here, insert 1/2 du. Now, taking the antiderivative of the new problem you created, you add 1 to the power, get u to the 7th. Reciprocal of 7 is 1/7. Multiply the 1/2 in front, that's 1/14. That's all you can do with respect to taking the antiderivative, so add on c. And now replace your variables so that everything's back in terms of the original variable x.